Good morning, friends. Today's lecture is about partial derivatives. Okay, all of you know the partial derivatives. You are studied in 12th standard. So here we study some theory of partial derivatives. Okay. So definition of partial derivatives is: let S be a non-empty open subset of Rn, and let f is a function from S to R be a scalar field, and let A is equal to A1, A2 up to An belongs to S. The partial derivatives of f at A with respect to ith coordinate, it is denoted by dou f by dou xi at A. It is defined as dou f by dou xi at A is equal to limit h tends to 0 f of a1 a2 up to ai plus h to an minus f of a1 a2 up to an upon h. Okay, so partial derivatives, we can calculate the derivatives of function with respect to ith derivative, that is partial derivative is the directional derivative in the direction of ei. Okay, in partial derivatives dou f by dou x1, we can calculate derivatives of nth coordinate. Okay, dou f by dou x1 at a. Okay, dou f by dou x2 at a. Okay, partial derivative means what? We have to calculate derivative with respect to every variable. Okay, every variable of that set, dou f by dou x1, dou f by dou x2, dou f by dou x3, and so on up to dou f by dou xn. And how to calculate this? Limit h tends to 0 f of a1 a2 up to ai plus h an. Here ith coordinate derivative calculate करायचं आहे. So ith coordinate मध्ये आपण h add केलाय minus f of a1 a2 up to n upon h. Okay, we will see this in R2, then you can understand very easily. Suppose f is a function defined from R2 to R. Okay, in R2 there are only two coordinates which are x and y. Okay, let a is equal to a1 a2 belongs to R2. Now we have to calculate partial derivatives of f at point a1 a2. So with respect to dou f by dou x1, we have to calculate with respect to x1, that is x coordinate. So definition will changes. Limit h tends to 0 f of adding h in only x coordinate, since we calculate dou f by dou x1. Okay, dou f by dou x calculate करतो. F of a1 plus h minus a2 minus f of a1 a2 upon h. Here we take only two coordinates since we are in R2. Dou f by dou y. Now we have to calculate partial derivative with respect to y. So definition will changes. Limit k tends to 0 f of a1 remains as it is, and we add k in on the y coordinate. Okay, ज्या coordinateशी रिलेटेड आपल्याला डेरिव्हेटिव्ह कॅल्क्युलेट करायचे त्या coordinate मध्ये आपल्याला तो एच के व्हॉटेवर जे आपण इलेमेंट घेऊ ते आपल्याला ऍड करायचं मायनस एफ ऑफ a1 a2 अपॉन. ओके, so this is partial derivative. Sorry, okay, this is partial derivatives. Remember this concept. So here we calculate one example, so you clear the idea about partial derivatives. So first example is find dou f by dou x and dou f by dou y. Okay, at point 0 0. Find dou f by dou x and dou f by dou y at point 0 0. Our function f of xy is 3x square plus 4xy plus 8y plus 6x. Okay, so now what is definition of dou f by dou x at point a1 a2 with respect to x? So adding h in first coordinate, means x coordinate. Limit h tends to 0 f of a1 plus h a2 minus f of a1 a2 upon h. Okay, so we have to calculate this. The point a1 a2 is here 0, so value of a1 and a2 are 0. So putting values of a1 is equal to 0 here, f of 0 plus h minus 0 comma 0 minus f at 0 0 upon h. So you have to here substitute f of 0 plus h 0, h 0. So coordinates of f is h and 0. So replace x with h and y with 0 in the above function. We get here 3h square 4xy, y is 0 here. So this term is 0, y is 0, this term is 0. So only 6h, 3h square plus 6h minus f at 0 0. Value of x and y are 0, so whole function is 0. So f of 0 0 is 0. So here remains only limit h tends to 0, 3h square plus 6h upon h. Taking h common and cancelling it from numerator and denominator, remains limit h tends to 0, 3h plus 6. So putting value of h is equal to 0, here we get answer is 6. So dou f by dou x at point 0, 0 is 6. Do you understand? It's quite simple. Okay. Now we calculate the derivative dou f by dou y at point a1, a2. Now calculating dou f by dou y, we add this k in second coordinate, means y coordinate. So definition will changes. Limit k tends to 0, f of a2 plus k minus f of a1 a2 upon k. We have to find this value at 0, 0. Therefore, value of a1 and a2 is 0. So, putting a1 and a2 is 0, we get limit k tends to 0, f of 0 plus k minus f of 0, 0 on k. Now, again, value of f of 0, 0 is 0. Okay. Now, putting value of coordinates f of 0k. 0k means value of x is 0 and value of y is k. So value of x is 0. This means what? This the term 3x square is 0. Value of x is 0, this term is 0. Value of x is 0, this term is 0. Value of y is k. So remains only 8k. So here 8k upon k. This k and k will cancel and remains k. So dou f by dou y at 0, 0 is equal to k. Okay. Do you understand? Next one is find dou f by dou y, dou f by dou y, dou z at point a1, a2, a3. Our function is log x plus y plus z, f of x, y, z. Okay. Now here we have to find dou f by dou x, dou f by dou y and dou f by dou z. Now let's check dou f by dou x at a1, a2, a3 is equal to, we have to find dou f by dou x. So we are adding in first coordinate here. Limit h tends to 0, a1 h f of a1 plus h, a2 a3 minus f of a1 a2 a3 upon h. Okay. So we have to calculate this f of a1 dou f by dou x at that point. Okay. So that means we are adding here limit h tends to 0, log of x plus y plus z. So value of x is equal to here a1 plus h, value of y is a2, value of z is a3 minus log of f of a1 a2 a3. F of a1 a2 a3 means log of a1 plus a2 plus a3. Okay. Remember the function. Function मध्ये फक्त ह्या व्हॅल्यू सबस्टिट्यूट करून आपण लिहिल्यात. नाउ we calculating this, taking 1 upon h outside here, 1 upon h into log of a1 plus h plus a2 plus a3 minus this. But we know that the rules of logarithm, in logarithm subtraction will changes to division. This means this will changes to log of a1 plus a2 plus a3, a1 plus h plus a2 plus a3 upon this a1 plus a2 plus a3. Okay. So this 1 upon h into log. So again use of rules of logarithm. This 1 upon h will be power of the function, that is log of a1 plus a2 plus a3 plus h upon this term raised to h. Now separating the denominator, here a1 plus a2 plus a3 upon a1 plus a2 plus a3, that becomes 1 plus h upon that term raised to 1 by h. You get it? Okay. So log of limit h tends to 0, 1 plus h upon raised to 1 by h. Okay. So we use here rule limit h tends to 0, 1 plus x raised to 1 by x. 1 plus x raised to 1 by x. So here we 1 plus x raised to 1 by x, 1 by x याचा रेसिप्रोकल घेतलाय, 1 upon a2 plus a3 plus a3 इथे ऍड केले, मल्टिप्लाय केले आणि डिवाइड केले. ओके. सो बाय दिस वे 1 limit h tends to 0, 1 plus x raised to 1 by x. So या टर्मचा आन्सर येतं e raised to that x, e raised to x. So this bracket is e and the power is 1 upon a1 plus a2 plus a3 and log. Okay. So again rule of logarithm, this will outside and log of e to e is equal to